Okay, let me open also a thing. Okay, so I want to do the evaluation first because I think it's going to be faster. Let's give us, I don't know, 40 minutes to try to finish it. I will explain you what we need to do, and then we can try to think together on how to do that. So how do you evolve pattern matching, right? How do you evolve that? So it is the following. You do the following. Okay, Nathan is here. Nathan can even correct me if I'm wrong. So what do we need to do evaluation of pattern matching? We need to evolve the value that you are matching. So that's what I'm doing on this line here. You need to do that. And then after you do that, you need to go branch by branch until you find the one that matches. So you're going to have to make a relationship between a pattern and a value. And when you do that, you need to bring all the binds that the pattern matching is doing in order to throw that into the environment, to the body. Does that
Yeah,
make
the
sense?
guard.
The guard is something that you also need to check, right? You only add the environment if, like, in two situations. If it doesn't have a guard, you just add it. But if
No,
it
no, no, no,
does,
no, no. Wait, dude. You need to generate the bindings, and after that, you look the guard
no, yeah,
because
that's
the
no, yeah,
values
that's
needs to
that's what is
generate.
happening here. But I'm not explaining necessarily in the order. I'm just saying that what we need to do. So you need to pick the binds, put in the environment, and then you check, like, then talking about the order. Then you check the guard because the guard needs to be. If it has a guard, you need to evaluate that and see if it's true in order to go to the body. But if it doesn't have a guard, you just add those things to the environment in order to evaluate the body. Right. So the way that I thought about doing that yesterday was using a fold. Unfortunately, that has a fatal flaw that I discovered after going back and forth with Nathan. At least my approach, right? I'm not saying that we can't do that with a fold. I'm just saying that the way that I did it is not enough. We need to make it better. So now we need to think about how to do all of that I just described, right? So you evolve the value that you are matching, and then you go through the branches with the patterns, and then you see if the value matches the pattern, and if it does, you put the bindings into the environment, you check the guard, and then you evolve the body. That's it. That's what we need to do. So ideas.
Uh, well, why can't you do with the fold? What was
Hmm.
going on?
Okay, what was going wrong? So the thing that is going wrong is that the first thing that I'm going to explain the way that I did it, right? I'm not saying that it is the best way. I'm not saying it is the way that you should be doing it. I'm just saying the way that I thought about doing it 2 a.m. in the morning, right? So the way that I thought is you're going to fold it, but what's going to be the final accumulator? What this final accumulator will have, right? So that my approach was that I want to save the environment with all the binds that I need and the body that I need to evaluate.
Wait, can you repeat that?
Yeah. So you're gonna go through. You're gonna do the first thing that you're gonna do is this.
No, only the last part that you said.
Okay.
Like,
So the last part is what I'm gonna have as my accumulator. That was the question that I had yesterday. And what I decided to do is my final accumulator will give me the body that I need to evaluate and the environment with the binds that I need to evaluate that.
the environment, right? So
Yeah. So a
why not an
tuple of two
approach
things.
of a maybe value?
Yeah, that the approach of the maybe comes to like we're using a find, right? Or something like that.
No, no, no. The fold returning a maybe value
But it does.
because you. Hmm?
Yeah, I didn't finish like, but the maybe here is just a detail in my opinion.
Hmm.
Because what I'm doing here, let me explain what this folder is doing. What at least my intentions, because this is wrong. But I can explain. So the first thing is that I'm gonna call the fold, right? And I'm gonna pass the list of triplets. Each triplet is a branch. So you have the pattern, the guard, and the body. And then the folder will start with nothing, right? And it will be nothing until we find the correct branch to go on. That is my intention. So the first thing that I do in the fold is to pick the binds, right? And then that's the thing. These binds, they are being created here, right? So for example, if you have a wildcard as the pattern for whatever value, that will return non-extra binds. Like you don't have extra binds to do, so it returns an empty list. And then you apply. It's very similar to the bind creation type checking. So then you do the variable, you just add it there, the PS, you just do it like this, and so on, and so forth. But this is the important thing, which is that every order combination just means that the value is not matching the pattern. That's it. But that's not an error, because we need to go on, right? We need to continue folding. So the way that, and that's where the maybe that I was talking to you, Nathan, would be added, because
Wait, dude.
go go.
Those errors that we have, one of the cases is the comparing the things on the R, right? Like
Yeah,
that's an
yeah.
error that you wouldn't need. The second is
The
uh,
second is if you have a label that is not. It is the same in the type checking, basically. So this label is not matching this identifier. The
did
the value that we pattern matched and evaluated has a name, and then the
did.
psum type that you are trying to pattern match is not the same name.
Indeed, I think we don't need the result, Lamos. We could just use the maybe then,
Oh,
because
because these errors will be theoretically catched by the type checking.
yes,
Oh, I see.
I was not thinking about that before, but indeed, we don't need a result there.
Okay, so this is just a maybe list.
Yeah, that would make oh man,
That would
that
solve
makes
it,
a
I guess.
lot easier. Yeah, that makes a bunch of stuff a lot easier.
Yeah. Okay, so if that's the case, I'm just gonna screw the entire comparison, and I'm just
Yeah, but
assume
we need to
things.
fix that function still. Like there are a few wrong things with that function.
Okay, I totally agree, but like again, this was done two things in the morning there, and each lint is saying that this is dumb, which because it is. This should be like that, and this should be. I guess only this concat. Yeah, only this. Yep. Then we can just screw this and that, and this is nothing. And well, I'm not gonna use the oops. I'm not gonna use the pure. Yeah. Okay, so but the intention is the same, right? But now we can definitely separate the empty list from the nothing, which is different than before, which is great. Because that was my problem before. I need to know if I match the wildcard and or if I just got something wrong and then I am just need to go on. I need to continue folding the thing, right? Okay, so we have the binds, right? So
Even
this
on that approach, I don't know why you were not returning a failure when in the no matched case stuff binds, empty binds.
because it's not a failure, right? I'm not gonna bubble up this to show an error and stop the program. I'm not gonna do that because that's not wrong. No,
No, that's the thing. It depends on how you are using this return, right? But just because you are returning the thing, the result, doesn't mean you have to bubble up. You could check to see if it matches or not.
no, yeah, I could put like another function to treat the result in here instead of doing that in the entry point. I could do that, but my mind it must exist a easier solution. And it does, which is this. Anyway, so then we create the binds, right? But now these binds they are a maybe, right? So we need to pattern match those. We need to pattern match those. So if that's the case, anyway, I'm gonna continue explaining because I don't think that's gonna matter. Then I'm adding the binds to the environment, right? This what I'm calling new environment. Then I'm pattern matching the guard. If the guard is nothing, that means that we should just go, right? We should just do pure just. Oh, we're gonna have to have the values here, right? So
We need
new
the float
env.
M in this case because I'm not sure if bubble. Well, I don't know how the float M works for sure.
No,
Can
no, no,
you?
it's not gonna be a fold M anymore. This, it's gonna be
Okay.
just a fold L. Yeah. So you're gonna put here. That's if that's the case, right? That's gonna be it. But if you have a guard, what you're gonna do? You're gonna pick the guard that has inside the expression and the new environment with the extra binds. You're gonna eval that. That will give you a value.
Why would you need the env as a return?
Oh no, this needs to be a fold M. Okay, go, Anathan.
Uh, oh, because you have the wait.
Yeah,
Oh,
this
because you have
eval
the vowel
expression. Yeah,
stuff. Yeah,
exactly.
forgot about that. But dude, why
What?
do you need the env as a result?
Why do I need the env as a result? Because I need to know, I need to have the binds that I acquire doing the pattern matching in order to evaluate the body, right?
But why don't you just return the evaluation result?
Because I thought about doing that, but what happens if I have to go on? What happens if I didn't find, like, this is what we are looking at is an iteration of a fold, right?
Then that's what I said. It's a maybe value, right? The return. If it is a non, like a nothing, then you can give an error to the user because that's what happens when non-matched, right?
Oh, I think I see what you mean. So if you don't have anything, you just go nothing.
Yeah, and that's an error.
But if you do have something,
Just return it.
you just return it. So instead of doing like I did, we can just do eval expression here, eval expression, new env, and the body itself, and we can just put that value in a just, and that's it. And this is a dot, and that should be kind of it, in my understanding. Yeah, yeah. Anyway, we have all the guard, and then the guard provides us a value, and then we check if the value is a v-literal bool true. Because if it is, that means that the guard succeeded. It's not on, it is a boolean and it is the value true. And in that case, now with Nathan's idea, we're just gonna return the expression wrapped in a maybe, right?
And you have the short circuit, right? If it is a sum, if it is a just, then
Yeah,
you
it's
just like
this.
just skip the
Yeah,
thing, right?
yeah. If you have a folder in which this is actually the XPR now, then you're just gonna skip it. Yeah, yeah. So now I just need to. Oh yeah, because the binds is a maybe. I need to do the case of stuff. But anyway, then you're gonna do that as a fold, and then before, because I had in my mind I had the environment in the expression, I was doing a maybe function throwing an error and etc. Well, this is still gonna be a maybe, but instead of doing like that, it's just gonna be just ID, and this is gonna be XPR because now this is a maybe XPR. Yeah. And then if you don't have, if you have a nothing, it's gonna throw an error, could not evaluate. But if it does, it's just gonna return, just gonna return the thing. Actually, this needs to be pure. Yeah. Yeah. So now we just need to do the pattern matching for the binds. So maybe binds case maybe binds off. So if you have an,
Wait, why are you using the arrow thing? Why?
what do you
We
mean
don't
by
need
the
that,
arrow
right?
thing?
Uh, why are you using the bind in line 2?
Oh,
With
because
bind I mean like
no. This is wrong. You're correct. This is like this. So you could actually just do case of this.
wait, what is this wingman?
What?
What is this wingman stuff? Complete? What is that?
You? I don't know what you're talking about. Can you?
Uh, yeah, after the off on this line.
Oh, this is part of the company mode stuff.
Okay.
So if you have a nothing, that means that you need to go on, right?
Yeah, just short circuits also, right?
Yeah, so pure nothing. But if you have a thing, so just binds, then you're gonna have to do that. Yeah.
Let's see. So,
Okay,
oh wait, that's
we can do
very
like
interesting.
this. So what is the problem here? Couldn't match
Are you
value.
sure? Wait, is this union the same thing as the merge?
I think that we don't have map merge. I think the union is the name of map merge.
Yeah, just take a look on the precedence, right? Like the new binds should override the old ones.
The new bind should the new bind. Oh wait, so there is a difference, I guess. I think it needs to be like this, like that. Yeah,
Okay.
it needs to be like that.
So if you have the binds, you do increment, you check if you have a guard. If you don't, you are doing something weird that we are going to change, right?
Oh, you mean here?
Yeah,
If you don't have a guard, you just evolve the thing, right?
yeah.
Yeah. So you're gonna have to basically copy paste this like that.
Okay. If you do, what is G? Oh, G forgot.
Yeah.
So then you evolve the guard and just check if it's true, because
Mhm.
if it's true, you just do the exactly the same. Otherwise, you just go on. Yeah, we might be missing something, but I think it's done.
Okay, but you said that we have some problems in this, so let's fix that as well.
Yeah. Uh,
But before doing that though, because I'm not seeing any sort of errors, I want to see if stack build works. And it does. Cool. Go. Let's fix this then.
Wait a sec. Yeah. So for any value, the wildcard just doesn't generate shit, right?
Yeah.
Yeah. So for variable, any value, just generate that. Nice. Okay, that one. That one, you need the internal pattern, right? That also generate binds.
Oh, you mean the PS?
Yeah, like the part that you are, yeah.
Yeah. So what we need to do with that?
Well, you generate the binds, right, with value and just concat with what you already have there.
Okay. So what you want me to do is to concat.
Well, by concat, I mean, it can be a cons, right? But just don't do the more expensive without need.
Value pattern. Okay.
Wait, but in which order are you doing? Because if you are putting the just on the end, just that's just silly, man.
I don't know what you mean, but okay.
Like if you have the big list on the start and
Um.
you are doing the concat, that's a
Well,
bit.
well, you can do like this. So you put the label and the value, and then cons. But this needs to be like this, and then you can just fmap that. Yeah, there.
He's suggesting something, right?
Yeah, removing this because before in the when I was using the other thing, it was needed. Yeah, like that.
Yeah, so we generate the binds from the internal patterns. We generate the one from the label with the value itself.
Mm-hmm.
I don't think there is any check needed. I'm pretty sure we check everything in the type check.
Yeah, no, having that I forgot about that. When you do have the barrier of the type checking, you can just forget about it during evaluation.
Yeah. Yeah, I guess that's when it's done. Now, sure, the disjunctive pattern. Yeah, that's also uh, not the easiest, right? Not hard, but not the easiest. Because you need to do the same thing as the folder is doing, basically, regarding finding the first one that matches and returning its binds
Wait,
of
I'm
those two.
wait, I'm confused. So what you want?
You have two patterns. You will do it on the first, like get its binds.
Mm-hmm.
If it is okay, you return it. Otherwise, you go to the next. If the next is okay, you return it. Otherwise, return the nothing.
Okay, we can do that. So what you said is that you're gonna do the first binds first, right?
Yeah, you want the first just, right?
Oh, you mean the first? I don't know the type signature though. Hugo first just. Okay, this. So you have a function that picks a
You even
thing.
have look at the first one. You even have like for non-list just to exactly.
Oh, you mean doing first just and then you call the two things?
Oh no, shit! Wait, what? Oh, because there you don't pass the function, right? You pass them like already maybe. But that's okay, right? Because they will not be evaluated really.
Okay, so it's gonna be create binds to value first pattern, and then the same thing again for second. And I need to have which package is this from? Oh, this is JC9 9.4. Yeah, we don't have that.
Is that too new or
Yeah, that's too new. Yeah.
so use the list
I
then?
think that I think that the latest one is 9.5,
And we are using
9.0.2.
oh
So how the heck
list
am
and
so you're gonna have to do the list, I guess. So first just, but this is from the data list.extra.
why do you have those extra by the way?
I think it's because like I don't have a clue why. Well, I do have a clue. It's because you don't want to like, oh, you want something just simple, just to manipulate lists in like 90% of the cases. Then you do data.list. But then people said, yeah, but what if you want this specific behavior, like very handy,
But
right?
why not adding the same thing?
No, yeah, that's what I said. I don't want. I did. I. That's my imagination, right? I don't know for a fact. I just think that
Yeah.
people didn't want to pick a simple library to manipulate list and blow and explode it with like corner cases, like with all of these.
Yeah, I don't guess that's a problem of the result of the compilation, because a language like Haskell is probably doing a bunch of like dead code elimination, and like if you are not using, you're probably not paying for it.
Mm-hmm. Okay, but there's a thing that we can do. There's a thing that we can do, which is to use the maybe function.
Wait, what?
Yeah, we can use the maybe function for this. Create binds, true, value, second pattern, and then what is
I
again the
started to
type
think it's
signature?
Haskell that makes me sleepy.
No, it can be whatever.
It's
If you
the
prefer to see
Haskell.
like list, oh, no, option dot whatever is the name in F sharp from you, it's okay.
I don't know. Haskell has like this is sleep powder. Whenever I look at code, I get sleepy.
Mm,
Why are
let's
you
see.
not using just the list one, the first just with lists? I don't know what you're trying to do.
Well, I am trying to um, make sure that we have Because I don't want to import another thing if we already are importing data.maybe, you see.
What the fuck? That's not expensive, man.
Okay then. So let's do it. So import data leaks extra. And by the way, I'm also sleepy today, so I may be a little bit slow.
I'm gonna stay until midnight today.
I hope not.
Need to make my database, man. Need to make it work.
I really do not hope that you're gonna have a problem. Second pattern. Okay.
So we go to them, actually calling the function, the first one that matches, so we get it back, like the
Yeah.
bind generator.
Yeah.
Yeah, I hope that's not wrong because it looks really simple. Wait, are we forgetting something? Wildcard, variable, as,
As
is
or
those are all the ones that are not specific, right?
yeah, we are just not using the p literal.
Oh yeah, because they don't generate binds, right? But
Yeah.
yeah, we don't even need the the wildcard also then, right?
We don't even need the wildcard. Oh, you mean this, right? Yeah, but I think it's great for
Oh,
readability. No. We do need, right? Because this is a
yeah,
just.
we do need the literals also because they are not an error. They should return the just empty.
So
We
you're
forgot about
talking.
that.
We are talking about yeah, but nothing in this case is not an error. It's just like go on.
Yeah, but it matches. If I have one, that matches. It just doesn't generate binds. I wanted like just to know that it matched. You see?
Mm-hmm. Um. Okay, so actually let's go here and let's add the first just here because the thing's complaining down there. Okay, so if you have a pattern for whatever value, but you have something that is p literal, right?
Yeah, not.
That return just empty.
No. It needs to wait. Wait. I guess I'm forgetting about the type checking stuff. Uh, the thing is, we want to know if it matches or. Yeah, I guess we need to check like literal by literal. Because if you have a string and an int pattern, that would match this and would be wrong, right?
No, but that will never happen because the type checking will not allow that to happen.
The type checking would not allow that.
Yeah, because if you have a value of type string and you are trying to pattern match a 1, type checking will not allow that to happen.
Yeah, that's true.
Yeah, but it's starting to get hard, this. Like, we need to remember everything that the type checking is leveraging.
Everything is discounting it. No, I still think it's sus, but let's go to the algebraic first.
Okay, so what is the algebraic one? We are just grabbing the values, we are totally not grabbing the labels of the view algebraic, because this is like left, right, or whatever, right?
Wait, that's the value, sure. And the p sometimes is a structure.
The p
Ah,
sometimes it also has a label, right? But this is different than this label because this label is the label of like left, right,
yeah,
of
both are this label.
yeah, but they are participating like one is what the language is expecting and the other one is like what the user set it.
Yeah, we need those. We need to check those.
But we already did that in type checking.
No.
I'm pretty
Uh,
certain we did that.
that's the thing, man. How do you know if the case is left, right? You need to check if the name is left.
Hmm.
For example, you have a pattern of a sum type, but am I pattern matching left or right? And
Yeah, that makes
is the
sense.
actual value left or right?
Yeah, that makes sense.
So if they don't have the same identifier, it's nothing like insta. If they do, mm, if they do is a bit more tricky
Yeah,
because then we need to check recursively.
yeah, which we are doing with the zip with, which is the what is the for all, right? In OCaml,
No, it's the map to.
map to, sorry.
Uh, Wait, what is the M doing there?
It is the aim of the maybe because this function returns a maybe.
Yeah, so we might not want that then, right? Because we want to check if all the things inside that list that you have, if they are all just.
No, but if some of them are nothing, I think the entire thing will break.
Like the whole function will return nothing?
Yeah, exactly.
Yeah, then I guess that's just it. Like if all of the internal ones are also just,
Mm-hmm.
then the whole thing is the just, like concatenating them,
Yeah.
right? Otherwise, it's just the nothing.
Yeah.
Okay.
Yeah, I guess that's it for evaluation then.
Yeah.
Okay, so now that we have that, well, we can try to test it, the evaluation without parsing, or we can just go straight up to parsing. What do you want, Nathan?
Opinion.
Okay, so let's go to expressions and let's remember what it was the pattern patching. Oh, it is in here. I commented
Nice to
that.
see that everybody is very motivated.
No, but I am motivated, but I know
I
that you
guess we
guys
should be.
hate parsing, so I'm not gonna even like if you guys
I
want
don't
to leave
hate
and do something
parsers.
else.
I don't hate the parsers.
Uh, okay, so let's uncomment this guy. And I do need to have an example on hand here. Um, let's pick this one. That. And then I'm just gonna comment this out. Okay. So let's think about that. So you're gonna have a match with an open delimiter. That makes total sense. Then you're gonna match the string match. Then you're gonna try to parse an expression, which also makes sense. Then you're making a pattern prime
Oh,
parser.
good. I
What?
knew that thing was sus. We need to check the specific literal and the thing that is inside. For example, you can match the number 3 and the pattern is 4 and it will match because like they are literal, right?
Wait, the pattern will not match. Well, now it is because we changed it, but if we remove that thing, like if we remove this line,
No, no, no. The thing is, Lemus, uh, first of all, we are not even checking if the value is literal, right?
yeah, we're not checking that. We're not checking that.
And the other thing is, let's suppose the user provides a 2, right?
Okay.
But I'm matching the pattern literal integer of 4. It's not enough to know that both are
Yeah, the
literals.
type checking
The
is
value
not
is
is
not.
not telling us anything. No, but that's what I said. If we remove this line, but that's the thing. If you have a true and you provide a
You
true,
have
that
to.
should pattern match. That's important.
Yes, but that's what I'm saying. You have to match specifically value integer, literal integer, and see if both integers are equal.
This is gonna be v unit. No, no, it's not v unit. It is.
I don't know why, but that part of the value is like very sus. Maybe it's not as obvious like the other one, or maybe it's just because we are in a session. I don't know, but
It's not as obvious you say. It's s unit. Okay, that makes sense. Oops. So this is Oh, that's the state. That is wrong. This is L unit. Yeah. Yeah. So this is that case, right? So then if you have a V, what is the name? V literal, we call it here. Okay. So
Oh yeah, I think it's harder the value because we are not worried about general things, right?
what do you
We
mean
are worried about like types. Types are very general. I only
Oh.
check its category, right? It's type.
Yeah,
I
yeah,
don't
yeah.
check
We
the
need to be
specific
more
element.
yeah, we need to be more that it has more details indeed. If you have an integer here and you have a literal and then you have an integer here, now integer value prime. So if both of them are equal, then you just do that, and then otherwise this is a nothing. And it's exactly the same for the three of them, right?
Yeah.
So this it's just gonna be L rational.
Well, then we can resume this code, right? The equality would work for the literals inside, like they are the same.
Yeah, makes sense. So we can just forget about that. Peak value. This value. Um, value, whatever, and yeah, that's it.
Yeah, if the equalities are like okay, right?
Yeah, the equalities, I think will work just fine. Yeah, but you were totally right. We were more worried about having like general stuff, but this is like very, very specific.
Yeah, we can like review like value stuff later because might be tricky.
Yeah. Okay, now we can go back to this. Okay, so we have a pattern prime there, and I'm assuming is this guy. This guy. Yeah, this. So open, close delimiter, so we have brackets there, and then you have a variable generic. Um, I think I'm gonna have to make a pattern specific parser because now we have multiple patterns, right? Yeah, I think that's gonna be best. Yeah. Yeah, because the remaining part, aside from this guy, everything is the same. Pretty much. So I need to make a pattern, patterns. ST expression. No, it's not ST expression actually. It is pattern actually. Um, Patterns, which is gonna be just choice of try, and then here we're gonna have the different patterns. Which patterns do you have? We have wildcard. We have literal. We have variable, and we have the p sum type, the pattern sum type. Yeah. And we also have the pattern s. Oh, we also have the disjunctive. Yeah. Okay. So let's start with the pattern wildcard. So this is just a parser of a pattern. And this guy will be p wildcard string this. Next. Uh, the next one is variable. Pattern variable 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 generic. Next one. I think it's gonna be
Oh,
the
something
literal.
interesting is to see the order that you actually have to use on patterns.
Yeah, for sure. Oops.
Why is
Wrong
that
button.
patterns, by the way?
Oh, you mean that this should be just pattern?
Well, it's a pattern parser, right?
Yeah. So this, this is literal. Can I just call the literal parser XPR? Oh, no, I just call literal itself. Okay, that's handy. So let's do that. So p literal f map literal. Okay. Okay, we are getting to the hard ones now. So the next easy one, I believe, is the S one. I may be wrong. Hope not. S. So what is this guy again? We parse a pattern and we give it a name, right?
Yeah.
Okay, makes sense. So this will be PS fmap pattern p variable generic. Yeah. Okay.
Wait,
Now
but
the
are you
hard ones.
considering stuff that you need to put, like brackets and parentheses and such?
Oh yeah, here we need to actually to put. No, we are not considering the brackets, the brackets themselves, because I think I'm gonna put the brackets inside this outer one, like I'm doing right here. See, like between open and close, I'm gonna put it in here.
I see, I see.
So this is only the internal content of the thing. Okay. So now we are getting to the hard ones, which is the or and the sum. But I need to put the name here, which is that you can have a skip, right? You can skip that. Then you're gonna put a string s, column s, skip again, um, and then you just gonna grab the name for me. Yeah, pretty much. Okay, so next one. Um, the next one is the disjunctive. Undefined. Which is gonna be the sum type. Okay. Disjunctive. Is that how I did that? Oh, I typed it wrong. Disjunctive is like this? Nathan. I forgot how to type that. No, it's not.
Disjunctive.
No,
It's
the
not
N is before.
Yes.
C. Okay. Okay, so now these two. Hmm. Now these two. Well, I'm gonna put the betweens for now. Between. Open. Close. Yeah. The sum type I think I know. I think it's this. So I just need to not use the tuple, and that should be pretty much it. So this should be p sum type that this, and then I just get rid of that. Yep. Okay. Now the disjunctive one. Now the disjunctive one. Okay, so something was going on there. Oh wait, this is not many this. This is many P. Pattern P. Yeah. And this is still wrong because we need to fold that. We need to fold. So I'm gonna use the notation in this guy. So we're gonna have to have a label. And then that. Then we're gonna have to have, I don't know, I'm gonna call it options. Yeah. Options, so this. Yes. Then we're gonna do p some type label foldel no wait, I think I'm confusing with the disjunctive one. How is this again? Oh, this is just a list, so it was correct. Oh crap. P some type f mapping that. I think this needs parentheses because of precedence. Then this. And then this. Yeah. This is the guy that needs the fold. This is the guy that needs the fold. So what was the syntax that you decided to do the OR again? You pick a pattern. Yeah. Okay, so I'm gonna call this one first. I'm gonna pattern mesh a pattern there. Yep. Then orders. And these orders will be a many one. I'm believing this also needs to be a many one, by the way. Yeah. This many will be a string. Well, a skip with a string or with another pattern. Yep. Then we're gonna do pure p disjunctive foldel p disjunctive the initial of the thing is the first and this, and that should be it. Is that it? Hello people?
Hmm. Let's see. um, so you are doing the patterns. Okay, inside the patterns, right? You're putting the possible
Yeah, the
things. There's the
possible.
guard, I guess. Let me read the others.
Oh, we are missing the guard. You're missing the guard. You're totally
Okay.
right. You're totally
So
right.
skip string as skip variable generic. Okay, that seems right. The other one.
Man,
You
it's
pick a
so
pattern.
fucking amazing the fact that we already made like variable generic, literal, and then we can just reuse them and like each parse is like 2 lines. That's so cool. But go on.
And then another pattern. Yeah, it seems correct to me. And then another pattern. Oh, but wait. In that case, the or. Oh no, it's a many. Never mind. Yes, okay. That looks fine. Just the
Okay,
one
so
now.
now we need to add the guard. Good thing that you remind me of that. Let's make the
Do you
guard
have the,
parser.
I think you still have the code. Just check first. I don't remember how it was.
No, we didn't. I don't think we made the guard. Yeah, I don't think we made the guard. In this iteration, we didn't have guards. We didn't have Yeah, it's an expression, I know, but I just want to make with the string, with the when and etc. So guard, this will be skip string skip again expression. Okay. Remember that. Wait, so you are suggesting to do a fold right? Is that it? What you're talking about? Can you speak, Nathan, a little bit to explain that?
Yeah, that's a fold left, I guess.
Yeah, but we are using fold left.
No, yeah, that's what I'm asking. Does have any what's the name? Does it change something the way we organize those things?
No, it does because remember, pattern matching the order matters.
Okay.
So
Yeah.
I think it's from the left because we have the first one has priority upon the other ones, and the second from and so on, and the third so on. You see?
Yeah, let me make the other example because it might not, I'm not sure. Because, for example, suppose you have this, right? And then we check first the first. And then it will be inside another R. And then you check first the first. Is it still the same order, I guess, right?
This is still the same order. Wait, can you repeat the last part?
Yes. So in this case, we have either the grouping or the C. We go to the left and then enter inside the grouping.
Yeah, but that's
Then
doing
we
a fold.
have
But
A
that's
or
a fold
B.
right. But that's a fold right, dude.
No, yeah. Again, I'm asking, does the way we are grouping matters something?
That's a good question. Hard to tell at this point.
Because I'm thinking that maybe it's the same order that he goes through the patterns, doesn't matter which way I'm grouping.
Mm-hmm.
Uh, the important thing maybe is you always take a look on the left first, right?
Mm-hmm.
Well, that we are doing right, so.
Yeah.
But yeah, probably the fold left is the more secure one.
Yeah, definitely the. Well, I would consider to be the safe one. Um. So we need to. Magetta remind me of the guard. We need to use the optional. Uh, aren't you using an option somewhere?
I think we are. I remember seeing it. It's just
Um,
option, isn't it?
no,
Optional.
I think it's optional, but I'm not seeing it here. So that's kind of sus. Let's go to declarations and put optional.
Where do we?
Oh,
Oh,
option maybe.
searching for rectile.
Yeah, option
Oh,
maybe.
option maybe. I don't know.
Yeah, so you put option maybe, and this is returning a thing. Yeah, this is returning a.
Reflex.
Yeah, yeah, that makes sense. That makes sense. So in order to use this guy, we're gonna do. Oops, this. Okay, so the first thing that we want to do is to parse a pattern, and this is wrong again. This is this. Okay, so the first thing that we want to do is to parse a pattern. That makes sense. So this is this. After that, we go skip option maybe with a guard. So guard, and then skip again, and that should be it. Yeah, that is it. That is it. But now we have a problem. All the ones that are asking recursively, now they are also having a guard there. You see? That's a problem.
Yeah, it's because that's not part of the pattern, right? It's part of the pattern matching.
It's part of the pattern matching. Part of the pattern matching. Okay, so then I can't use the open and the close in here. I need to do it outside. Yeah. Yeah, okay. That's okay. So let's just forget about that. Do this. Do this. And that's about it for this guy. And now let's uncomment this guy and finish the parser. So how that's gonna work? So you're gonna have that. Then you're gonna have open delimiter. Yeah. Then you're gonna have the pattern. Then you're gonna have the pattern. Yep. So pattern P. And then we can just do it in here. So it's gonna be skip. Um, yeah, skip. Um, well, should we create a parser for that? Why not? Guarded pattern. Yeah. So this is gonna be, I guess, using a tuple to combine them. Pattern P, this. Um, but of course, this can have skips on it. Yep. Skip again. And then you're gonna have an option, maybe, of a guard. Skip there. Okay. So that's gonna be that. That's gonna be that. Oh, you also have to have the close delimiter here. Yeah, close delimiter. Yeah, makes sense. Let's go back to our example here, which is down up here now. So this. Yeah, so pattern, this, then the guard, which is this, close bracket. So we are closing this bracket. Then we have a branch, which is this, or it should be that. So let me guarded pattern. And then we're gonna have a body, which is this. Then we're gonna have many of those. So branch, and then close delimiter, which in this case is this guy. No, it's this guy. The other is from the the function thing. I think we are done.
Awesome.
I am. I am. I want to
I
test it.
hope you are.
I want to test it. Yeah. Okay. So let's go to an example here. I want something simpler than this, but is this even gonna be compiled? Let's see. We are defining a neither
No,
there. Then we have
the
a
string is wrong. It should be unit on the print.
string is wrong.
On the bang string, like
Yeah.
x is unit.
Oh, yeah, that makes sense. So let's pick something a little bit more uh, humane, let's say. So let's put one here. Let's put, I don't know, two.
Why
Um,
don't you make a different value? Because the guards will fail, right? Okay, nah, never mind.
the guards will fail.
No, no, never mind. Like they will also.
Yeah, we can do like this. Yep. Okay, so then you have a pattern or a number 3. Then you're gonna print.
Oh, yeah, the prints. The last
So
print
I
needs to be in
enter
here.
in first branch. Uh, Wait, where do we have our stuff? Here.
Stuff.
X this evolve region.
Oh,
So where is again? I need to reopen this, right?
no, just to no, yes, silver mode. Yeah, everything is red.
Yeah,
I can't
everything is red.
remember.
Now you understand.
Yeah,
Everything's
because
red.
we just marked the special words, but
Yeah, but can't we do two types of special words?
yeah, we can. That's what I say.
Yeah, I would put the types, no, the definitions, and like,
Function names with like
yeah,
green, yellow.
exactly, exactly. But anyway, I enter the first branch. This will always be true, right? If I send a one, this guard is always a true. Let's
Mhm.
reverse this guy to. I don't even remember. Do you have this operator less than? I
No idea.
really don't remember at all.
I don't as well.
Operator, operator.
We do. Okay, it's the
We
last.
only have the less than.
Okay. All right.
Okay, so second branch, right? And catch all.
Why don't you print X to see if it's printing correctly?
Yeah, that's a good call.
To see
So
if it's
let's
getting
put
the point.
integer. Um, and let's put x here.
Let's see.
Okay, wait. Um, let's call this guy match test, right? Uh, oh wait, the print either is actually doing a pattern match with a sum type. Yeah, it is doing that. So what we want to do is to call this guy um, match test, right? And we will need to pass a value to it.
I thought you were gonna call on the REPL.
I know I don't even. It's baby steps. Baby steps.
Okay.
So let's do the first. Let's do the first one then. Yeah, let's do one. What are the odds? What are the odds?
Well, it seems that it's compiling.
No, it is there, but.
That's a really good sign, right? It could
Yeah,
not, maybe it wouldn't even
yeah, I
compile.
agree that maybe it wouldn't, but usually it does, and we're still takes times to debug, especially because this is gonna be a more real, like realistic example of the type checking and evaluation in a single shot, right? So let's do it then. So stack run, no stack exec, spatula, and let's put the file examples pattern matching, no pattern match,
Pretty much.
and let's ask for the parsed version. Yay!
Okay,
Line
but it's just a
6,
dumb space on a variable name it was expecting.
this line. Oh, I think I know.
Hmm. Oh, after
Um,
the keyword? Is
yeah.
that it?
So control this, control S, yes, and then express. Okay, so match. Then we have a skip. Wait,
And there is
line
a skip there.
here.
Yeah. Oh, but it's pointing to the right.
No, but we are
Oh, but it doesn't
ignoring.
matter, right?
Yeah,
Yes.
we are ignoring that. Oh, I know what is this. I didn't add to the. Oh, we need to check the order. Nathan is right. The variable needs to be the last one, and the wildcard as well. Um, we need to add to the expression. We didn't do that. Pattern
Oh,
matching
I
P.
see.
And now we need to take care. Yeah, this is wrong. This is gonna be so wrong. So the last one for sure needs to be the variable. The one that is also at the end is the wildcard. Um, I think literals is fine.
Yeah, variable you remove it from there. Come on, Lemus. What happened to Lemus, man?
There's some
This
time. The sum type. What's the part of the sum type length?
Wait, I didn't listen to what you guys saying because people entered here.
Okay.
Yeah, what is the parser of the sum type? Or better, what is the syntax for it? That's enough.
It's this.
Mm, that's
I'll be
very
right back.
interesting.
You guys can discuss that. But my feeling is that this also needs to be at the end, the Python type. I'll be back.
Yeah, so you see,
What, Nathan?
so the variable could be just as the left and right are written, right?
Wait, could be.
Just as the left and the right are written. Especially because we
Mm.
left could also be like all lowercase as far as I know.
Yeah, yeah. Mm-hmm.
So sometimes you want to match just the constructor, like it doesn't have a value inside, right? How do you distinguish that from a variable? You don't.
Yeah, that's a problem.
Oh
Uh,
man.
but wait, I think we are. No, 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 wait. Oh man, this sucks actually. Well, we can come up with another syntax.
I don't know how a few languages do, because I guess that cock lets you declare the constructors like lowercase.
I'm back.
Yeah, F sharp allows you to do this as well.
No, but gives a warning, right? At least.
No, it does, but it works.
So what you guys decided there?
I think we have a problem with the like sum types and the variables. Like, how do you distinguish both?
I think it's the presence of a space.
But what if the sum type has no space? Has no element inside? Ta-dum.
Oh, this is why in the beginning it was a many known one then. Okay.
Yeah, but then there's no different. It can't. It's very ambiguous then. Shit. I think we need another syntax. You gonna go up?
Nathan, what do you think?
Well, let's say.
Put a bang on the front.
Yeah.
Yeah, when dude, that fixes everything. Put a bang, done.
It might be the easiest solution because if you have to change what the variable could be, that
No, yeah, I don't want to do that.
might not be so fun.
Yeah, so just add the bang like the others. That's fine.
So if it has the bang is a constructor, right?
Yeah.
Or the opposite. Do you
I
have
got.
skips or not? No, you put just before, right?
Yeah, just before.
Uh-huh.
That's a bad sign.
Well, wait, you didn't fix the file, right?
What do you mean
It
fix
didn't
the
have,
fire?
it didn't
Oh,
have bangs before the.
yeah, but that's still bad, even though I didn't fix it.
Yeah, that
Because
had.
that
I
seems
think
like
that's recursion.
yeah. I'm also thinking about that.
Comment this through. Can oh man, you can't do this on the REPL, I think.
Let's do the following. Uh,
Have you looked if you have any left recursion on the parsers?
wait, I forgot how to make comments, people. It's been so long. Oh, it's like that. Okay. So
Maybe in the OR
Yeah, it's
pattern, I
because
don't know.
my mode I didn't point to those comments. Wrong. Yeah.
I think it's this, right? Yeah, what's this? Okay, so let's remove this sum type case. Eh. That's a really bad sign.
Uh, yeah, take a look on the parser.
Look at your CPU while you do this.
Right. Well, let's try.
It's just fine.
6%. Still 6%.
No. Look at one core, right?
Okay, the RAM increased 2%.
No. I'm saying like just look at one core, like because it's probably just one process, right? That is hanging. It's trying to do garbage.
No, 95% average.
Yeah. So
Okay, so we need to see for left recursion in here, I guess. Do you spot that, Nathan? Or I do this.
oh yes, on the left.
Oh. Makes sense, exactly.
Oh man.
Just do the opposite then.
Yeah, the up. Yeah, okay. In fix.
Like Haskell, right?
Prefixo.
Oh, wait. No, but then the column S doesn't make sense anymore, but
Yeah.
Yeah, we're gonna have to change the name, for sure.
This kind of sucks because
Because
like how are we gonna bind? Okay. Yeah, okay. Like the name. Yeah, okay. That seems fine to me. Like you're just gonna change the order, right? But it's okay, I guess.
yeah. Um,
yeah, on the STs is still.
Yeah, the same thing.
Oh,
The same
that's
thing for
actually
the
important.
disjunctive, right?
wait. Nathan said that something is important.
That's actually important. Oh shit.
Same problem. Line 7
Line 7?
down. Line is 6, 7 down.
People
Oh,
entered here.
yeah, they are.
Can you explain again?
Pattern P on line 6 down. Same problem.
Oh, you mean here?
Yeah.
Lemons.
Yes.
Yeah, so remember that we have to check in the S if the name that I laid alias into, it's not already generated, right? If they are not repeated.
Mm-hmm.
Now we need to change the order of that check, right?
What do you mean?
Well, maybe we don't, but because we were expecting the user to write, at least when I was doing the ST, that he would do pattern and then the name, right? So that also mandates the order in which you check, right?
What about with instead of named?
That's better.
Wait,
And then
which,
on the pattern you make S, like
which
with,
language do we?
and then it's literally written.
Which language do you use with for something? Oh, okay, the match with, right?
Mm-hmm.
Match with Python.
Oh, but Python is for resources, right?
Here's a suggestion, Lemos. We're gonna go to the pattern match SW. Line, yes, this. So what about? Okay, there's not the S. So with and then S there. What about?
Why
Wait.
would you need that?
Well, that's readable. I just
Uh,
well, you know that this pattern as the variable.
oh, I see.
That's not that bad. Like I have some worse, definitely worse.
It sure fixes the problem of left recursion.
Yes.
It is still weird for Lisp though, because
Yes.
as far as I know, you always have a function before this, right?
Yeah, but I think. Yeah,
That
but I
will
think
work in
with
Ruby though.
No, but wait, a function is just a label, right? That's why you don't have left recursion.
No. What I mean is in Lisp, I guess you would usually find a function before those special arguments with
Yeah, but
colon.
it will always be a symbol. Like you
Oh,
can't fall into left
wait. This is
recursion.
actually super ultra different, people.
What?
Yeah, because here in this example, this is the pattern, right?
Yeah.
Yes.
So I need to change this to pattern P.
Yeah, but then you don't need to change the the rest, right?
Yeah,
Like the
yeah.
type and such.
And then that. Um, yeah, we can just do parentheses, this, and then I guess variable generic skip. And then we can just P S fmap.
Yeah.
Okay.
And the S is also missing.
No, if you want to add.
So skip, then string S, skip S.
The bad thing is that column is not really a tag, right? Like a true key in Lisp. It's just a random bullshit we added there.
I guess that kind of stuff is done in Ruby though. Like
Oh, probably.
I almost sure.
You are almost sure.
But
We need to
it's
fix the disjunctive one though.
Yeah,
I'm not
it's
sure
the
if
same
they
thing.
call keyword list.
It's the same thing. It's just a many.
No, we can just add the or in the beginning.
Yeah. That was the idea before, right?
Yeah, pretty much.
And then now you can have one or many, right?
Yeah, one or many. But then
Okay.
that's a thing. Wait.
Oh, but do we need to break the first from the rest?
Yeah, that's a
Yeah, I
problem.
mean, you can do a try head and then see if you have one or many.
Let's put this pattern, and then let's put this there. Yep, that. Then we do one, and then we do many.
Yeah. I think it can be many, just many.
Yeah, that can. This needs can be. Well, but that's weird. You have
Oh,
an
I don't
OR
know
with
why
one
you
one
would do
option.
this. I don't know why you would do this, but well.
Yeah, you wait. Oh yeah, for that syntax works, right? Because you are not using yeah. Oh no, but you can't construct the est, right?
No, yeah,
If
we
it's
you.
empty,
Yeah, that needs to be a menu
Yeah,
line.
that needs to be. Yeah, we
okay.
need to be able to. Yeah, that's true. Okay, so let's take another look and see if we are missing something now. I
Can
really
you go
want to
down?
remove the bang though. I really want to remove the bang.
Oh, I think. Let me see. If we add another special thing apart from the bang, we can.
That's not removing the bank, that's changing the bank.
Well, uh, what about? I don't know, man.
Yeah, it's
What?
not easy.
Is either that or changing the variable? Or putting some bracket, I don't know.
Like changing the variable so
Thing
it
a
doesn't start with
bracket.
like capital letters, right? Something like
Yeah.
this.
And I don't think that's a great idea. Like
I don't like it.
I do think it's a great idea, but not right now. Maybe from the start would be
Yeah, just leave it there and we think what we do with this later.
yeah, use the bank for now, man. Just
Okay.
Oh, the when. Did you fix that?
The
Oh,
when?
no, we don't have a problem of pattern on the left.
Yeah. Yeah. The when is
Just,
there.
are you
Um,
yes.
matching the guards though? Where?
wait, what?
Where are you matching the guards, by the way?
Here. Like we
Okay.
this is this we have
Optional.
the pattern and the maybe here.
Mhm.
And then we add the body in this. So now this is a pattern and maybe a guard and a body. See?
Yeah.
And then we get many of them. And then we
Dude,
just
we have
construct.
so many skips that doesn't even make sense.
I don't know if it doesn't make sense, but we are totally allowing
Look,
freedom at peak.
yeah, look the guard. The guard has skips in it and surrounded.
Yeah, why not? Let's see. Okay, so, or am I missing a bracket?
How
Or,
can't you write your own language, Lem?
what?
How can't you write your own language, man? You literally chose this. You invented.
Well, I definitely participated on doing it, but, well. Which line is complaining there? Line 17.
Isn't it a parenthesis that is lacking on the or? I thought it was like one
Oh, it
bracket.
is. It is. It is
By
this.
the way, one of the few things we have on our README is pointing to the grammar, and it makes no sense now.
Yeah. Oh yes. But here's one thing, like, do you need that green parenthesis there? I don't think so.
You mean this?
Yes.
Oh, you don't, dude.
Imagine doing that without the highlighting, man.
Well, that's a true Lisper. That's you don't even need the
Dude,
colors.
imagine coding in Como Lisp. Not even Como Lisp. Imagine coding like, I don't know, those Lisp 2 things in like a Lisp machine in MIT in the 80s with like a colorless display, like literally black and
Yeah.
white.
You always talk about those situations. I wouldn't do that to save my life, dude.
The motivation of Nata is zero. Do you need another or?
No, we don't. We have a bracket. It's what Nathan said. I
There,
don't know.
that's what I'm saying. I don't think we need this second or.
No, we do. We want that because. Oh wait.
It's just, if it's on the front, it's just a list of.
6, column 6.
Yeah.
I think I know. It's because a literal doesn't have a bracket there.
I don't understand as an application.
Oh no. Wait. This
Or not,
this needs
it's not
because
pattern.
each pattern requires
Yeah,
each pattern
But
requires
dude, this or, I think it is wrong. Like, you shouldn't have an or again there.
I think we
The
do.
second or. No, dude, it shouldn't.
We should.
If we, why? That is totally
Oh,
inconsistent.
okay. I think I see what you're talking about. I don't know if that's totally inconsistent,
yeah.
but okay.
It is, man.
Okay,
There are
so
2 words for 2 expressions. Why?
okay, so this is like that, I guess. So let me
Yeah.
see what is incomplete.
One could do pattern, and then all the next ones are or and stuff.
One could do what?
Why would you need the like many ors, right? One could use pattern and then a list of or and pattern.
No, but that's the thing. We already discussed about that yesterday.
I'm saying what one could do. I'm not saying what you guys should write.
Okay. Um. Okay, so this is just this. Okay, so the first one requires the or, and then all the other ones are just separated like normal
And this
patterns.
is even better. Oh man, let me show you how this is awesome for pattern matching. Go back to the pattern match.
Awesome is a very strong word.
Delete the second or. Enter. Before the 3. Yes. It's perfect. Dude. You can read, dude. You can read.
You can read.
Wait, that is.
If you try to indent it, it's not so bad.
Wait, that when doesn't make sense there, right?
It ends the print as well.
It does. This does.
No, the like second thing, the guard is inside the like one pattern.
Yeah. This is a guard.
Guard is only one for the whole branch, not for every pattern in the branch.
Are you
Wait,
sure?
what?
Of course.
I'm 1,000% confused.
Yeah. So you have a branch, right, with a pattern and maybe a guard.
Oh,
So
he's
for
talking
every
about the
bench,
disjunctive, right?
No, I'm talking about every branch. Every branch has either 0 or 1 guard. But if you are doing the guard with your OR there, then you would be able to do multiple guards for multiple patterns, right?
No, but that's what we have.
Yes.
An OR it has multiple patterns, right?
No. Guards.
Oh, no, he's right. Yeah, he's right. Okay, he's right. This needs to be this. Yeah. Because this is like this it's not a guard per
Pattern, right?
pattern. It is like for the entire branch, right?
Yeah.
Yeah, I see. I see what you mean. So it would be here. Yeah, it would be there. It would be there. Did you get it? Not my get.
Yeah, I get it. You cannot declare one when per thing in a disjunctive way as well.
Yeah. So you're gonna do a or, an or,
Yeah,
and
okay.
then you check like if
But
any of these match
Yeah, the
and the
first
guard is true.
line three as well, right?
dude,
Line
Oh no, line
three.
three. Okay, never mind. This parentheses is because of the pattern.
Yeah.
but it might not work for you to parse that way. Because if this is inside the whole pattern, but your when it's outside, like in the match on the parser, then you would have in twice also.
Wait, I'm confused.
It would
Yeah,
have
go to
what?
your pattern matching parser.
Yeah, so we grab the pattern. So this is the or. So imagine that this is the
What is
or.
the what is the when in the pattern matching parser?
In the pattern matching parser, it is in here.
Is there, right? So and the pattern is before, right? So they are so the way we are doing, they are still inside the OR, isn't it?
Yeah.
It is inside the or.
So it wouldn't work, right?
It will. No, it will. This it will. Because remember that the pattern doesn't have the brackets. We add the brackets later. So
Oh.
it's or, and then this, and then the guard, and then the bracket.
Oh, I see.
So take a look. This is that bracket. Actually, I think it's good for us to try to like read the parser and write it down. So open bracket, match, right? Which is like we want to have the most possible freedom. So this is actually skip because I don't want people complaining about like, oh, it's not indented or whatever. Then you're gonna have a skip there, so this is gonna be that. Then you're gonna have uh, an expression p, right? So this will be, I don't know, oh man, whatever value, right? A value that is an expression. And then you're gonna open another delimiter after skip, so it's gonna be like this, right? Then then we have the guarded pattern. The guarded pattern has the pattern P and the pattern P. Oh wait, the pattern P. Oh, I removed it. I'm dumb. That's why it's not working. Open.
By the way, I think the paper about the parser combinator shit it has on the last sessions saying how to deal with the skip stuff like in another way.
No, that's better. Anyway, so now we have this open bracket here. Oh man, I think I see the problem. It's because the first is got is exactly the equal to the let, or am I confused? Wait.
To the left.
Yeah, because when you do a let in Lisp, you start opening two brackets to do the let. Oh, no, you do let and then you open two things to do your stuff. Um, like I'm just asking if that's the case also here. This is the syntax that we
Well,
want, right?
you have a list of like branches, right?
Yeah.
So, but they don't need to be inside one bracket because they are the rest, right?
Mm-hmm. Okay, so this open delimiter thing is doing absolutely nothing then. Because it is this guy right now that we are this open delimiter is parsing. But this is per branch, you see?
Yeah.
This is per branch.
Range, and then you have like pattern and expression.
Yeah, so this open delimiter is totally wrong. This shouldn't be here. So let's backtrack a little bit. then when you are parsing each branch, then we add it. So this is like that. This is this. And then each thing has let me make it bigger here.
What
A
is
guard.
that EBS?
Oh, this is the pattern and the guard. Let me change the name of that. Yeah. So the guard and pattern, this has a pattern, and each pattern now has its own bracket. So now we are adding a second bracket here. Yes. Then you're gonna have a pattern. So let's put that one there. So then when and this, and then each pattern also closes. Yeah. Then we're gonna, after the guardian pattern, we have a skip and an expression. So now it comes the body. So it's gonna be the print stuff. Print stuff. And then after we have this close delimiter to close the branch. So it's this. And you're gonna do that a bunch of times. A bunch of times. And then after we're gonna close it to close the match. So it's gonna be this. Yeah. Yeah, I think the reason it was not working is because I forgot this between here. Let's test that out.
Let's finish this because then we gotta start with our machine learning library for Silverware.
What?
Machine
No, man,
learning.
it's
Does
not a language if
anyone-
it doesn't have machine learning.
Wait, does anyone here knows anything about ML? Like,
Well,
not the
The
good
very
ML.
basics.
Not the good ML.
The good amount.
Column 9, unexpected column there. So is this when here? Needs to be. Line 16. So why is this a problem?
Oh, you didn't finish the pattern, right? That's the problem.
What do you mean finish the pattern?
Shouldn't the when be outside the purple?
No.
Then that's inconsistent with the
No,
other.
no. Wait. I think you're correct. I think I am dumb.
Or should you make a new parenthesis on the one?
No. We are enough with the parentheses. We are enough with that. Oh, dude, I remember why I removed the between. Is because we want the guard to be inside the pattern. So putting the between in here is actually forcing to have this.
Yeah. So keep it this way. Let's see.
Keep it this way.
No, now it's at
More
least
parentheses.
No, dude. Now at least it is consistent with the others. This is still junky, but it's better.
It's still junky, but it's better. Okay, so this is the way that you want.
Why isn't the when a list of three then? A list of pattern, when, and the body.
I think it is still inconsistent the way you wrote because then on line 3 down, no, now 1.
No, this is
when
wrong. No, this is still.
yes,
We're gonna have
should
to
be
change
outside.
this to this.
Yes.
Yeah, we would have to do that. Nathan, you suggested something. Go on.
Yeah, it's basically that, but that being like in brackets.
Of course it was in brackets.
Person.
Oh, totally cursed. Okay, so we are talking about the pattern not enclosing the guard and the guard coming afterwards. That's what we're talking.
Yeah.
Okay. So just for the sake of being aligned, the parentheses, so I can follow. Let's try this. Right. Let's try that. Okay.
That's coming quite better, man.
Okay, so let's see what the parser complains now. 16 column 24. Okay, so we have an extra thing here. We have an extra thing here.
Oh, you need to parse the when now, right? The way it is.
No, but we are already
Oh.
parsing it the way it is. Look, we pick the pattern, and the pattern already have the open and close brackets there.
Okay.
Then we pick the guard optionally, and the guard has
Oh,
the
wait.
what?
You close the delimiter.
Yeah,
Which delimiter are you closing?
I'm closing the.
There's a closed delimiter.
Oh,
It's
okay.
already on the pattern, right?
Yeah, so that's why when I was thinking about doing inside, that's why I added there.
Okay.
Yeah, but again, it was the same thing with the lets. This amount of brackets, I get lost. 17 now, so now we jumped a line. So line 17, column 11. It is a opening. Opening. Okay, so
Maybe
it's the
those
OR.
things.
It is the OR.
Maybe those 2 and 3 are not in thing.
No, but they need the brackets because they are a pattern.
Okay.
And each pattern has its own open and closing brackets.
Can you see exactly which one is that column?
Yeah, we're gonna have to count because Emacs.
Hey,
It doesn't have the.
No, there was a thing to show there.
I think it's this one.
Hmm.
Oh! Lack of skips.
Makes sense.
The-
I need to compile, right?
Oh, I need to compile. I forgot. I didn't change the right. I changed the left
Not,
one.
it's not small talk.
No.
All right. Now.
Okay, so now the problem is with after the width. My
Oh,
guess is
this
skip.
needs also. No, this needs brackets, right? Isn't that the pattern?
Like this?
Yeah.
Okay, so let's attempt to read that.
Good luck. We don't
Can
have
we
a
try
pretty
to
printer.
just run it?
Well, we can.
Just run it, man.
Yeah, I prefer that alternative.
You typed what is the value?
I
One.
entered the.
So yes, it is one.
Let's
That
turn
is-
this to be not true. So now we should go to the catch-all, right?
That's right.
Dudes. Okay, let's remove our comments.
Oh no, here we go.
Here we go. Yeah, pretty much.
You need to update something there?
No.
No, they don't have guards nor any big.
Okay, so what's gonna print? It's gonna print left. It's gonna print this is a test. Unexpected Y.
Why?
Some type. Oh, this is a variable now.
Oh, I see.
Makes sense, makes perfect sense, yes.
Dudes! Okay, we need to test the OR pattern because we didn't test it yet. So let's put 2. And it's wrong. Oh no, but this one is also wrong. Okay.
Try a
Okay.
negative number. I just
3.
want to see negative numbers.
I don't.
Do they work?
Can we parse negative numbers, dudes?
I don't know. Good
What
question.
is that question?
I never tried, so.
I
Oh,
don't recall.
come
Put
on.
like a -10 there instead of 0.
I don't think that's gonna work.
Let's see. does.
It parsed.
How it parsed? It's another question, but
Oh, it is there. Look,
yeah.
we do have it. I don't remember when I did it, but we did it.
You know that Matrix scene in which the guy is saying that he doesn't even see the code, he just like see the actual things, right? That's Lemos right now. He doesn't even see the XT.
The
No more.
looks at this and immediately sees the ST. Let me see how can I make this. Let me think. How would I make the library to make the parentheses like transparent?
No. I think that we need 2 things for the Emacs, at least Emacs. Auto indentation
Yeah.
and things not read.
Okay,
Yeah,
that
this
we
red
can
is
do
very.
both. We can do both. I'll check here.
Okay, no, but we need to
Yeah.
test more. Nathan, give me. I want more. We need to test more. We still have to mess around with the
Okay,
or and the sum type.
you get the fucking energy
Tell me a
to
language, Nathan.
do that.
Ruby.
No,
Ruby
no,
or
wait, man.
Emacs.
I'm focused here. Uh, so that's this, right?
um,
Like
but-
that's one of the patterns. The rest you can do like just
okay, so you are
some.
basically suggesting to put shoe here.
Wait. I want to get the warning on the first branch, right? About the song.
No. Yeah, but the first one with someone, I think we can achieve
It's
the
an
same.
R.
Yeah, it's an or with choo, basically.
Okay. Yeah.
Literal choo is unreachable.
Yeah. The other case.
Okay, the other case is to when you have a left with whatever. So is this?
Uh,
Yeah.
Wait,
Test
give
it.
me a second. I have some like complex test case, I guess.
Yeah,
On
this is one situation in which we cannot call victory yet because
Victor?
yeah, we can't call victory like oh we are done. Pattern matching is finally done.
We do that? You
No, we usually when the thing parses
Why don't you
and
make
executes.
a binary tree?
Make a binary. We can't. We can't
Why?
because we don't have
Recursive
recursive
types.
ADTs.
Oh, we still don't have it? I thought we did it.
No, we did recursion. That's a different thing.
Oh, we did recursion, that's true.
That's a different thing.
Yeah, and unfortunately, it doesn't apply to like the principle that we did to do recursion. It doesn't apply to have recursion in the ADT. That's the only point of the phase one that I think we're not gonna finish. Wait, speaking about that, control this, go to docs, features.
Oh yeah, we even forgot about
How
this.
do I transform in org the to do to done? I forgot.
Just shift and then right, like arrows. Shift,
Oh.
hold,
There is saying a prelude library.
shift,
Okay,
hold,
if you
and
notice
then
that
for right or
language.
left.
Shift and what?
Right, like arrow.
Yeah, but that I
mapped
remapped
something
that.
else. So meta x org to do. Oh, or
Uh,
just change it to done.
Okay, so
No,
algebraic
don't do
data
function to
types.
do.
Well, this is not done actually because we still have to do nominal records. But this is not Haskell required because we didn't want to have the full separation from of pattern matching and guards. So just guards.
We're
This is
certain
done
another-
because of
Benevides?
Benevides. So this is the one that I think we're not gonna finish recursive types.
Yeah.
Which is actually should be in here. Actually, yeah, that. Well, in talking of doing that in order, I think it's gonna be this, that, and I think well, we already started doing the prelude of like reading files, reading lines. Um, Making compilable is going here. I remember another one, which is to do modules, simple modules.
We kind of have it, right? It's just half broken.
No. Yeah, I don't. Did I remove it when we declared that doing it the dumb way is hard?
No idea.
I don't think I removed. So it's possibly it's still here, but it's totally not worth it.
Lemons, I have the example here.
Okay, go.
Yeah, you just have to modify some stuff, right? Oh shit, wait, the fucking Discord format. Wait a bit.
Okay, so we are very, very, very close. Next session will be nominal records, and I am putting a lot of faith that we're gonna finish there. Because Nathan said that he has a genius idea.
I didn't say genius, and I do think you're being optimistic. But yeah, so what differs on the example that I send you is that we don't have tuples, right? So instead of that, you use a sum type that only has one constructor and carry two things inside. You use a sum type constructor as a tuple.
A sum type constructor is a tuple. You mean making another thing that is not an either?
I will write in Okama for you.
Holy Jesus, dudes.
Like this.
Type tuple. Tuple AB.
Like it's generic types, right? Well, actually, it doesn't need to be generic. Right?
Okay, I'm
So,
still kind of confused, but let's go. So you want to make some sort of a tuple. So let's go here.
yeah, don't start with this actually. Do another sum type. A sum type that has. Here, it's formatted so freaking bad. Let me. Okay. Do.
Wait, I don't know why we can't just implement the tuple in Silverware itself. Like, it's kind of weird.
Because you can't pattern match.
Because you can't pattern match. What do you mean?
And you don't have. Wait, why can't we implement a tuple?
Yeah, like, why can't you just say def algebraic and then you receive two things? And then you're gonna do something like this, I guess.
Oh, wait. So create a thing that has like the constructors A, B, and C.
Create a thing that has the constructors A, B, and C. So I'm assuming we're talking about making, I don't know, whatever. And then A, B.
Yeah, they don't carry anything.
Oh, they don't carry anything. I don't remember. I don't think we keep the parentheses, right? I don't recall. I don't recall. So which one is this? ADT.
Oh, listen.
Oh no, but this is only has the fancy one. Okay, so I'm gonna assume that when you don't have it, you don't need the parentheses. Okay, go.
Yeah, so then do another one with. Wait. Yeah, then do another one with C, D, E, I guess. Wait, let me see. Yeah, do another one with C, D, E, maybe.
Okay, sorry. People entered here. Can you repeat that?
Yeah, create another one, but with the constructors C, D, E.
Okay, so this is... Okay, let's give better names. So this is gonna be the anything. Anything. And this is gonna be something.
How is that better than whatever?
Because whatever and whatever true is worse than anything something, yeah.
Sure. Yeah, do another one.
I
E.
don't see a difference.
Yeah, do another constructor element.
What do you mean?
Another constructor. E. Yeah. So now you do the tuple with the types fixed on that, right?
The
On the
types
left side,
fixed on
you have anything. On the right side, you have some.
I'm 100% confused. How is this mimicking a tuple?
Well, a pair. Sorry.
No, even a pair.
Well, you only have one constructor that has a left side and a right side.
Okay, so we're gonna make an alias, I guess.
No. Just call left. You call tuple there.
Mm-hmm.
also, and then the left is anything, the right is something, and you don't receive generic types.
Oh, wait, but then we can do an alias. Let's do that. Let's try reusing the things that we already made before.
What do you mean by alias, man?
So, oops, yeah, that. This is gonna be tuple. And this will not receive anything, which I'm gonna assume is just this. And this is gonna be a neither of anything and something.
No, either doesn't work, man.
Why not?
Because that's not a tuple.
It's one or the other, right? It's not both.
Oh, we want to have both. That's what I am confused. Okay. So it's gonna be like that. But instead of this, it's gonna be tuple. We don't receive anything here, you said, right?
Yeah.
And it's gonna be left anything. Um, anything and something.
Yeah.
Yeah.
And you don't have the right.
Oh, man.
Oops.
Yeah, now you have a tuple and we can do the same that you did there.
Do what? This?
Yeah, so you will pattern match something, right? By something, I don't mean that.
Best name in existence.
Yeah, that's the worst. Yeah, why this needs to be a function? Just do the match like alone.
No, because we can't parse that.
We can.
No, well, we can, but that's not gonna execute and do anything at all, I think.
If you print.
Of course it will.
Oh, if I print inside it, that's what you mean.
Yeah.
Anyway, I want to do like that. Just go, Nathan.
Yeah, so let me.
So it's gonna be something, right? So it's gonna
Well,
be
it will
C.
be left, right?
Yeah, left. C, for example, right?
No. The first one is a wild card.
Oh, this.
The
Actually,
other one.
this.
Okay. The other one is an OR. A OR.
Or.
Of. Of C and D.
C, D.
Okay. And then the next branch. You match a left with a B.
Mm-hmm.
Bang, right?
And
No, not bang is only in the constructor name.
no, that's a constructor
No,
name.
that's a constructor.
Wait, what?
C, D, B, they are constructors.
Oh, that's true, because otherwise they are variables.
Beautiful.
Yeah.
Terrible.
So like
Terrible.
this second branch, you are going to do we use the C and the D, right? So you will use E and C. Yeah, and then there are the only two branches that you have. So it should give a warning on the last C of the second branch.
Okay, so let's put string.
I'm feeling that's not going to work, man. I don't know.
This is the first branch. Second here. Okay.
And then you call it, right?
I think it will fail line 11. Let's see.
Oh,
Okay.
yeah, you don't need to call it, right? You just want to type check, yeah. So go on.
No, but I do want to call it. What do you mean? Print
Doesn't
tuple
matter. It's a type check.
left. Then we're gonna have to put. I don't recall. Do you have to put these things?
The types, yes.
Yeah. Yeah, because the left is a type application, I guess. Yeah, like not type application.
No, you're not generic.
The types. Those are the types for the left and right, right? For the either.
Yeah.
What?
So
Types? Which types?
well, T star U star.
Why are you passing a neither? It's a tuple.
No, but I'm passing the left. I'm constructing the tuple.
Yeah, it doesn't take types. It's not generic.
Oh, I just pass. Wait, but then how do you create a value of this?
Just the expressions,
A
right?
sec.
Left and then expressions.
Left and then expressions.
Like AC.
Like this?
Yeah,
Wait,
I
but that's my
guess.
question. Shouldn't it be like this?
No, that's for types.
Oh, that's true. Okay, that's true. That's true. There's a parenthesis at some point that I did by mistake. Yeah, here. So that shouldn't be like that. I think that should be like this then. Is that?
I don't know, that's the syntax, right?
I don't know. Let's go to the ADT one again. No, it should be parentheses indeed. Should be parentheses. Because you only put brackets if you're gonna receive stuff. We're not gonna receive anything. It's just this. Like that. It's just this. Yeah, like this. Well, at least that's my understanding. No. I don't recall how we parse this. Don't recall. Have we tested this before?
I guess.
I don't remember we creating a type that doesn't receive generic things aside from
Oh,
alias.
I see. I don't know then.
That is
Source code.
very weird. Okay, so let's go to types in the parsing. Oh, but that's not a type. That is a declaration. Def ADT. This is the one. This is the one. Let's see. So you cannot receive. You can just have a name, like a list of. Wait. Oh, this is the name of the kinds. Okay, so who cares? So this is the name of the tuple. This is the
Yeah,
possible
check
name of the kinds.
where you are using those name kinds because they should be optional, right?
Yeah, so the name kinds are not optional, actually. That's my understanding.
But can it be an empty list? If
It
so, just
can be an empty list. It
like if
can
the
be.
arguments
No, it can't.
come
It
in,
can't be an empty list because this is many one. It can't be an empty list. It can't.
just receive something and don't use it.
No, we can also try to convert this to a many normal many here.
Are you sure that's doing what you expect? It's a lot.
Oh, dude, dude, dude. Hold on, algebraic, algebraic. Let's test. Why not?
I will be doing the next test.
Yeah, go there. Okay, is it still having problems parsing the thing? Oh, wait. Wait. This is parsing the left stuff. And this is parsing how many types we have. And we do have types there. Okay, so my understanding is that the type parsing is a problem. No, but this should be parsed as a type placeholder. Are you sure this is not a type applied? Like to do type application?
I don't know what you're talking about.
You don't know what I'm talking about. You don't know what I am talking about. You don't know what I am talking. Choice. List of the types. What is the final thing of that? It's a text and a list of types. That should be exactly what we need then. That should be exactly what we need. Okay, so let's just create a test SW. Oops. Let's put it in here. Wait, now it did. What? No, the parsing is correct. It's not a parsing problem. Which is kind of weird. Okay, so now it's
Wait,
complaining.
what do you mean not a parsing problem?
It's not a parsing problem. Because
We were literally having a parsing error there. Now,
yeah, it's
yeah,
not.
now it's something else.
No, it's not a parsing. It's not a parsing problem in the def algebraic. It's a parsing problem in some other place.
Oh,
I'm assuming it must be the. It must be. Yeah, screw this and that. Let's try to parse this. We know that until this, it parses correctly, perfectly.
isn't he saying like the line in the column that he's failing?
Yeah, line 13. This. Oh, this. I have absolutely no idea if.
So, wait.
Okay.
Pattern D is unreachable? I don't know why you're printing a list there. Pattern D is unreachable? What?
Pattern D is unreachable. That's what it's saying there.
Left. Parse.
Yeah, but that doesn't make sense, right?
Doesn't make sense at all. Let me see. The order he's talking about the left also isn't reachable. Left. Dude. Yeah, something's very wrong. Wait, where are you printing this is unreachable, man?
No, that's a tough call. In a bunch of different places.
I don't think so. It's one function, I guess. Do the looking on the text, man. Do a search.
Print warning. Okay, so these
Why
are
not
the.
is unreachable? But yeah, that's the only ones you have. So are they all inside this get next pattern? Actually, holy shit, that's a huge name.
They are not. Some, I think the last one, yeah. So one of them is a type check expression.
All
Oh no
these
no
unreachable cases.
no. The all reachable cases is all in the same function. It's
Yeah,
all
so let's
this.
go there. Let's see what we are printing. Ah.
Okay, so you only have three options. These are the only three possible ways to print that.
Yeah, but what is curious is, you know the second one? He's saying that the whole thing is unreachable. And I suppose if it's only something inside that is responsible for this, it would print only the inside one. See?
No. Can you go? Which line are you talking about?
Go to the error that we got. The
It's not an
warning that
error.
we got.
It worked.
Yeah, take a look there. So you see the second warning is talking about the left being unreachable.
Yeah.
Yeah, so he should, like when working correctly, only say about an internal one, not about the whole left. Show me the source code that we are running.
Yeah. So these three
No,
cases.
that we are running the, yeah. So
We should not
let's,
have an unreachable there, dude.
yeah, we should not. Anything and something. So it does receive a double.
No. Wait. This is unreachable. The C is unreachable. This is the second
Yeah,
C.
yeah. So we match the left. That's the only thing we have, right?
Yeah.
So yeah, so the first one, he's saying what about what's the first warning? He's saying the C is unreachable.
No, the D is unreachable.
The D. How is that, dude? C D E. The type's correct, but it shouldn't be unreachable. We never matched anything on the second element of the. Hmm.
I don't think we have a choice. We need to go through the.
Yeah, I can't even localize the.
Okay, let's
Yeah,
go.
let's go there, then get next stage. So let's go one by one. So it gets the state, it gets a pattern, and that's it, right?
Mm-hmm.
So if it's satisfied, doesn't matter the pattern, you just say it is unreachable,
Mm-hmm.
sure, and return satisfied, perfect. Um, Now the next one. Doesn't matter what is the state, but it's not satisfied, is unsatisfied. If you get a variable, then it's satisfied, the wildcard also, the disjunctive one. Doesn't matter the state, first and second pattern, we just get the next one with the first pattern and use this next state with the second one. Okay, now the S. So
Now the S.
state and the pattern. Indeed, it depends on only the pattern to know if it is satisfied or not. So I guess that's exactly it. The other ones are what? Oh, state boolean when it has nothing and it has something, it's just that. When it has something, you check if it's the same. If it is, it's unreachable, otherwise it's satisfied, perfect. I will not check the other one. Let's just
No, but you need to
wait. What
because
is the sum one? No, I will not check the literal ones.
the
Wait, what
someone
is
is
the
this.
sum one?
This.
Okay. So that's the state, right?
Mm-hmm.
Yeah. So state, the constructor states and the constructor pattern, yeah. So the label and constructor patterns. Yeah, that one is harder to check.
But we are
So
doing a map. We are getting the constructor states, and we are
wait,
mapping.
I need to go slower than that, Lams.
Okay.
Uh,
Ignore
so
the let. Ignore this let for now.
yeah, so constructor states. Okay, we map the constructor states.
Yeah, to get the next constructor states.
Wait, the constructor states. Those are a list of tuples, and the tuple, yeah, has a label and pattern matches. You are mapping that.
Yeah.
That's weird. I think you should do a find and then a zip with, not a. Oh, okay, yeah, I see, now the map. Okay. So if the identifier it's not equal to the label.
No, this
Oh wait.
is equal. If the identifier is equal to the label, you zip with.
No, yeah, because I'm returning identifier and next. Okay. So if it is equal, I do something. Otherwise, I just return states, sure. And if it is, I zip it, get next pattern, receiving the state, and the constructor patterns. Okay, that looks totally right. And then I have next constructor states. Okay, what I do is if all next constructor states, all element of them, I also do a all in them with this.
Yeah, we
Yeah,
go to
this
the constructor
second.
state, we grab the second, which is a list, and apply another all to that.
Okay, because every element will have the labeling of their matches, then we get the second, and that results in a list, and we check if all are satisfied. Dude, that looks correct, just correct. Well, not correct, equal to the other implementation. So take a look on the get initial state.
Okay. Get initial. This. Okay, here.
I'm back.
Yeah, the units, looking for the
Fixed.
unit.
No,
Rational.
we fixed we fixed the thing that was breaking before, but now the unreachability is wrong.
Yeah, really wrong. So those are, yeah, I guess those are all the types and constructors. What we do is we map the constructors. Okay. Ah, ah, ah. Constructors. Okay. Why? Well, we map it.
What's happening is, for each element of the outer map, we have a tuple. But we want to map only to the second. We want to maintain having the label. So we use the second. And we want to do what with that internal list? Map again. Right?
Can you show me the type of S sum? Yeah, so it receives. Oh, that's very strange.
No,
Why
yeah,
do you
this.
have a.
Just ignore it. Just pay attention to this. I think it's
Okay.
saying that this is a function that receives this in the first position and returns this.
Okay. So let's see. You have label and pattern match. That's for each constructor,
Mm-hmm.
right? And you have a list of those. Dude, I guess that's it, man.
What?
Like, I guess it's equal.
Oh, equal to the other implementation, right?
Yeah.
Yeah, I'm pretty satisfied with that.
Yeah, go back there. I want to see the map that you are doing. Can you explain the second? Like, what is the order that?
Yeah, so this map is mapping each one of these tuples. You agree?
Okay, text and
This,
type.
yeah. And then but we want to apply a mapping only to the second member of the tuple. Do you agree?
Yeah.
Then we use the second. Then,
Okay.
what do
Wait,
we
wait,
want to?
wait, wait, wait. What is the result? Well, the result of that thing that is there, right? The between parentheses is a function, right?
Yeah.
So the cache symbol there, it's the apply, right?
Yeah. We are applying this map to the second.
Okay. So
Yeah, this is the
that,
type. So we receive a function that picks a list of types and returns a list of pattern matching states,
wait,
which is this
that's the
map.
type of the second?
No, that's the yeah. I'm describing what the second is expecting.
Okay.
So it's expecting a function that picks a list of types and returns a list of pattern match. That is the inner map there. This is the inner map. Map get initial pattern match state. This is this type that has this type. Then the element that it expects aside from a function is a tuple, which is a tuple of a
Wait,
label, and
I'm not getting that, dude. Give me the type of the second.
it is this. This is the type of the second.
Oh, those are instantiated.
Oh, if you want to have the this is the generic version below here.
Okay.
You receive a
So
function with a b to a c. You receive something that has the b in the second position.
a tuple of A and B,
Yeah.
right?
And you receive a function that transforms the b to a c. And
Yeah, indeed, just maps the wait.
yeah, it just maps the second member of a tuple. Well, not
Map
of a tuple, of a bifunctor, which a tuple is.
is expecting a function and then the tuple.
Yeah.
Yeah, makes sense. That's the function that yeah, dude, that also looks right.
Yeah, that's the problem.
Oh,
That's a
dude, that would
problem.
be such a headache.
But let's try
Uh,
to reverse engineer this. The only way to print this amount of information, like left, whatever, 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 is if one of these three prints are wrong, right? I don't think it's the integer. And I don't think as well that it's the boolean.
what do you mean by the prints are wrong? There is no way the prints are wrong.
No, the prints are being called in a wrong condition. That's what I mean. We are not or we are verifying something wrong, or we are not verifying something.
We went through all of this. I couldn't identify like right away.
No, yeah, that's for sure.
Dude, I'm thinking about running the gist and checking the same thing. Because that way we know for sure already that the problem is with the gist, and then we can focus on that. Otherwise, we don't know if it's a translation mistake.
Yeah, that makes sense. I would be I would be surprised if it is a translation mistake, but
I also, because I just checked it, man. Yeah. Oh,
what?
yeah, let's check the folder. No, not the folder, but the type check of the pattern matching expression.
Okay, that we can definitely do. So T.
Wait, what are you doing? And the code of the type checking of the pattern match expression.
Oh, okay. E pattern this. Yeah, that. Let's go then. So the first thing that we do.
Wait. What is this should not be possible? Good job to parse. What is that first one that you are doing?
This is when you try to pattern match without branches.
Oh, okay. Hey, but why do you need that?
Exhaustiveness, of course.
You don't. You are matching the whole list.
Oh, you're using a fold here. Okay, so we can just get rid of that.
So let's see.
Yeah.
We type checked it to match.
Yeah.
We reduce it. Type. We have a folder. Then we call the fold M with the folder.
And then
It
nothing.
starts. This nothing is what? Oh, it's the resulting type.
Yeah.
Initial state for the type.
Yeah.
And the list of the branches. Let's take a look on the folder, expected type and the state, the pattern, the guard, and the body. So we create the binds, right? That will wait.
Yeah, we create the binds.
Case it doesn't match. Like it has the wrong type, it's an error, right?
Yeah, it will. The create binds will already throw an error.
Wait, the things that can happen inside the create binds is either an error because it has a different type, right?
Mm-hmm.
Or unreachable. No, not unreachable. Do we have any warning create binds? What
I
are the
don't.
errors that we have in create binds? Let's check.
5.
So we have like the last one that is completely generic, right? No, the last one that is, yeah, like if you go down there,
Oh, you mean down here?
yeah, you have the generic one, right?
Mm-hmm.
The other ones that you have, uh, is checking if the binds are not the same.
Oh, in this one the
Sure.
order matters, by the way, so you should pay attention to the order as well.
What?
Yeah, the order matters in this case, in which we are
Yeah,
pattern matching.
yeah, but we are not even getting those zeros, right?
Yeah, we're not getting those errors.
So the order one for the pattern, recurrent label identifying pattern, okay. That's for the, oh, that's for the S. S, okay. Indeed, the other one is constructor cannot be found, different length, and repeated bar. Ah. Wait, did we check that function? We didn't, right?
What do you mean by check that function?
Yeah, yeah. Well, it's not a problem because that's not giving an error, but we like didn't look at it. But yeah, repeated bind found. Sure. Uh, yeah, all are errors, and it should be like an error for everything already. Like go back to the folder. Okay, so if I do get the binds,
Yeah.
right?
Then I'm going to explain here. I am folding the part of the environment, right? Because we have three parts in the environment. We have the kind context, the type alias context, and the variable
Yeah,
types.
you are implementing the env. That's easy to say.
Yeah, I'm incrementing the env here with a fold.
So your type check guard there.
Yeah, so let's go there.
Oh, that's result T. Okay. If it is a nothing, it's okay.
Mm-hmm.
If it is a just, I type check, and if it's a boo, if it's a boo, it's okay. If it's not, it's not okay. Perfect. The check match body we can do already.
Oh, sorry.
Wait. Okay. Yeah. So if it's
Let me break this line for you.
it receives the expected type and the type. If it doesn't have one, it's okay. If it has one and they are the same, it's okay. Other, yeah, that's perfect. Let's go back. Hmm. So now we get the next state, right? State and pattern. And then we do the just body type. Then we check if there is a guard, then state, yeah. Then we match case state if it satisfies. That's the expected body. Otherwise, we give a warning, and then still, dude. I guess that's one to one left. Like all the things that we checked, I guess are one to one.
Yeah, I'm pretty satisfied with
Ah,
that.
man, you run here, dude. Well, I guess I have a easier time to run the F sharp code.
Yeah.
So yeah, let me open here and I'll share this.
Yeah, okay, I'm gonna finish the streaming now.
Oh.
So, bye.